However, I still have, this is the
Oh,
shoe
wow.
that I printed.
Wow.
So as you see, it's completely comfortable. It's lightweight.
Mhm.
You can wear it. You can make it for your feet because you can vary any type of size, any type of shape that you have on your foot. You
Mhm.
can make it with a 3D printer. Therefore, there is a need. What's the issue? To make this, it takes me 32, 38 hours to print
Oh, wow.
one.
Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And before we get started, just wanted to mention that we have released material science merchandise for those of you who want to support us or just express your passion for MSE. You can check out more of the designs at itsmaterialworldpodcast.com/shop or by clicking the link in the description. All right, let's get right into it.
Hello, everybody. Today, I have the honor to introduce another David Zapata, otherwise known as DavidZIndustries. He's accumulated massive followers on both Instagram and TikTok, with 225,000, 100,000 on TikTok, and has shown the amazing possibilities that come with 3D printing with flexible filaments. You can just scroll through his Instagram or his TikTok page and you'll see all these incredible devices that he's printed, such as consumer products like a video game controller or soccer cleats to soft robotics for medical applications. David has taken a very unique pathway to success, so we're very excited to talk to him more today and learn about the applications of flexible materials and what it has in store for the future. Thank you so much for joining us today, David.
Absolutely, guys. It's such an amazing privilege to be here. I'm so excited. As soon as I heard about you guys, I was like, yes, we need to make this meeting. We need to show people the amazing possibilities of all materials that we can do with 3D printing.
We felt the same way when we saw your Instagram page. You're like, we got to make this collaboration happen. So let's start with maybe how you became interested in 3D printing, like flexible materials, and how you amassed such a large following while doing so. So I know you told us you started as an electrical engineer. So I was just curious, how did this area catch your attention and how did you get to where you are today?
Well, it was step by step. So after I graduated for electrical engineer, it was back there in Colombia. I came here to United States. I'm located in Florida. So I started being interested in automation. Since it's my field, automation, electrical engineer, this is my thing. But in the beginning, I was more focusing industrial automation. So I was focusing more in PLCs, more about machinery. Then after a while, I have always this passion for researching what's in the industry right now, what's coming up. This was 4 years ago, and I was like, wow, this thing called 3D printing is kind of interesting. Then I was researching, reading at a point that I was like watching hours and hours of videos on YouTube every day. Then one day I was like, let's buy this 3D printer. I got my first 3D printer in 2019. Yes, 2019. It was January. And then I started my journey. And my journey started actually on YouTube. I posted the entire video of how I opened the box. The quality of the video is terrible because at that time I didn't know how to manage my social media. As you might know, the path is very rough. And then I started printing with PLA, which in the 3D printing community is the standard filament, the standard material. Then I found TPU and I said, wait a minute, this is incredible. After that, my life changed and here we are.
And just to clarify, TPU, you mean thermoplastic polyurethane, correct?
Correct. So in the world of 3D printing, it's known as flexible filament. The issue is that this is not very accurate because there are different types of polyurethanes. There is TPE, which is thermoplastic elastomer. Then it's TPU. There is always PPE. There are many types of flexible filament. The one that I'm more interested about is TPU. Why? Because it is easy to print. It has so many properties. You can make incredible things. And it's just an unexplored field that I think that as a community, we need to go more. Like we need to embrace it.
Awesome. Yeah, especially coming from a material science point of view from us, could you kind of walk us through what makes TPU, like what properties it has that makes it so unique compared to these other range of materials that you just talked about?
Sure. First of all, it's 3D printable. The fact that you can melt it at low temperature makes it very easy to manage. Then it has abrasion resistant, impact resistant. You can make it oil resistant. In the 3D printing world, you can mix it with different additives to give more properties or less properties. UV resistant, you can make it biocompatible for things that go inside your skin. There are many things that you can do with TPU. It's very used in the sneaker industry, like to make shoes. There are also catheters that are made out of TPU. There are different things made of TPU. And that's why I think that the future of 3D printing is with TPU and all the other materials, of course.
What does the compatibility look like for printing TPU? Like how easy is it? Is there any challenges to it?
That's the thing. The 3D printing community, when you start, do you guys have a 3D printer by chance? Any of you?
I don't personally own one, but we have it in like our
You
Georgia
should.
Tech facility.
You should. So the day that you get a 3D printer, you're gonna see that the most common material is PLA, as I mentioned a few minutes ago. So everything that you print different than PLA, you're gonna compare it with it. Compare with PLA, TPU is very, very slow. So people find it challenging because to get quality and printing speed as well as with PLA is not going to happen. So it's very common to see people frustrating, getting a spool of TPU saying, this doesn't work. My printer doesn't print TPU. And it's not true. The thing is that you need to trick the 3D printer. You need to know the settings. It's like a recipe. You cannot just get the spool and make that it's going to make magic. No, you need to know how to operate the material. And after that, you're going to enjoy the filament.
Yeah, I think that you kind of talking about like each individual material has its own set of like almost instructions to how to use it properly. And so I guess as someone who I have done a little bit of 3D printing, but it really is like if I ever run into an issue, other people just happen to like, oh yeah, you just have to change this setting, like maybe increase the temperature, decrease the speed. How did you build up this knowledge base to actively tackle your unique projects?
I think that everything started when I challenged myself to post one picture or video per day. So that's how the journey started. I got my printer. I was like, I need to post. So I was designing every day, designing my own designs and making them. Once I faced TPU, it was getting more difficult because I was like, whoa, I need to research more because tomorrow I'm not gonna be able to print anything. This filament. So I changed it at the different speeds, different retractions, different temperatures. I was changing everything until I found the sweet spot. What I didn't know is that in the community, this wasn't very explored. So people started asking me, whoa, how did you do this? How did you do that? I was like, wow, guys, now we have knowledge here. And I'm more than welcome to spread my knowledge because as a community, that's the point. I don't want to keep everything for me. I want more people printing with TPU. And that's the point of the community.
Wow. So what drove you to want to post like every single day? So for us, we thought, just like you, it was going to be rough at first, but we just continuously would want to improve the quality. So on your end, what was that story like? What was the motivation there?
The motivation, I believe that 3D printers are the future of manufacturing. In the beginning, since I didn't know about 3D printing, it was for me unclear of how to do this. I have my notes of 2019 saying, try to discover how 3D printing can affect the world. And that was my purpose. In the beginning, it was just an exploration. It was a journey. After a couple of years and a few thousand of followers, I was seeing and interacting with the community, discussing with them about what they think, how we can make this, how we can make that. I started seeing a pattern of, okay, if technologies like, for example, cell phones, follow this path of, okay, early adopters, then the vast majority of people having it, 3D printers can follow the same thing. The problem is that they need to be adopted. How to be adopted? You need to simplify the process. You need to make better materials, better designs, simple networks. That's how you make something available. It could take 10 years, it could take 20 years or 100 years, but I believe that it will happen.
Wow. So I guess with all of these projects that you've done, can you tell us more about the applications that TPU has to offer, and maybe like what your favorite project has been so far?
So far, well, in terms of applications, I found three major applications. Consumer goods, as I said, 3D printing, manufacturing. Consumer goods is the easiest thing to make with a 3D printer. Then you have fashion, anything related with hats, bow ties, shoes. Even right now, Adidas is making shoes with TPU. The difference is that they don't make it with a 3D printer, they make it with injection molding because for them it's cheaper and they already have the supply chain for that. But TPU can be used, and it is being used for that. And the third one is soft robotics. As an engineer, I'm very, very curious about this new field. Is robots that are soft. Just imagine them. Like, it's just such a disruptive thought that the TPU can bring and 3D printing can bring a lot of the table.
Awesome. Just going back, we actually did an episode on soft robotics. I think it was episode 19. And so we would love to hear, because we know how soft robotics, and we talked to a professor about it, but what exactly can TPU especially bring to this field? And like, what type of applications could we see with soft robotics with the inclusion of 3D printing into the field?
Yes, as you might know, robotics nowadays, most of them use silicon and pneumatic actuators. So you use air pumps to make movement. However, with TPU and 3D printing, you have a different field, which is compliant mechanisms. A compliant mechanism is just a regular mechanism that is made in one part. To make motion, you don't have hinges, but you have just a solid bendable part that is able to control the motion. They are superior in terms of performance and price. The difference is that it's so hard to make them and to design them. I have made a few of them. I've been reading this for years, and it takes around 6-8 months to design a compliant mechanism. Because there are so many, you have to deal with equations, nonlinear equations, and to solve that into any type of software is very complicated. So sometimes intuition is the best way to go. So you need to try, error, until you find the perfect compliant mechanism for a soft robotic application.
Wow.
And so on the topic of just compliant mechanisms, I did like a 3D design course, and I created like a very simple compliant mechanism, nothing crazy. And so just for the listeners who don't know as well, it's like, if you think of like a lever and you can think of it as like a seesaw, you would think that a seesaw is like comprised of like an axle and just like all these different parts, but a compliant mechanisms, just with TPU especially, would be able to bend in both ways without breaking. And so I want for you to kind of talk on that more, and like, what does the design look like? Because as engineers, we talk about stress and fatigue. So if we take a plastic, just like, I don't know, a paper clip, and you bend it back and forth, that's a metal and it can withstand it. But if you take like a plastic fork and you bend it back and forth, it's going to break. So how do you specifically with your projects try to tackle this feat?
So the way to tackle it, you can create compliant mechanisms in two ways. You can create compliance with materials, or you can create compliance with the structure. The best way to approach this issue, the issue of fatigue, is a combination of both. You need to find the right amount of material that is not too flexible, but not too rigid. If it's too rigid and then you force it, then it's going to increase the fatigue over time. But if it is too flexible, you're not going to be able to control the motion. So you're just going to have a yellow part there. That being said, there are different types of compliance. You can create distributed compliance, and you can create what is known as a flexure. These flexures are points that are easier to make, easier to design, but the amount of stress that is there, the amount of energy that it holds, it's super high. That's why a distributed compliance, it's the most efficient way, but also the hardest way to make it.
So since we're materials engineers, I'm curious about the structure of TPU and what makes it so that it gets these properties like this impact resistance and the flexibility. Because I know, just from a polymer science standpoint, it's like if there's large pendant groups that could affect like its rigidity. So what exactly about TPU gives it all of these amazing properties?
The fact that TPU, I'm not very knowledgeable because I'm not a chemical engineer. I've worked with chemical engineers and I've seen how they compare with, for example, nylon, or they compare with TPE. For example, TPE has the same structure as TPU, but the monomers are arranged in a different way. How it affects, it is more flexible. Sometimes being more flexible is good, but for a 3D printer, for example, especially there are different types of 3D printer that we didn't mention this in the beginning. The ones that work with thermoplastics and the ones that work with resin. In my case, I work with thermoplastics. However, with resins, you don't have this problem of having too much flexibility because it's light with liquid. But if you are pushing filament through a nozzle, when you have something too flexible, the nozzle is going to get stuck because it's not able to, it's like the printer cannot handle rubber, for example, because it's going to make a ball there. Therefore, the right combination and the right structure is the key. And that's why TPU is a very, very good material for 3D printing.
Interesting. And so I'm curious if you know about this, but a common solution to what you're just saying, if it's too flexible or you want properties from two different ones, you can make like copolymers. So taking the monomers from two different ones. Where's the field in that aspect where TPE's flexibility maybe desired, but TPU's processability is much better?
Something interesting about TPU is that you can have the additives. In the additives, as I mentioned in the beginning, gives different properties. One of the most useful properties that you can vary with TPU is the flexibility. So you have different short hardness. The most common, the one that people use is 95A TPU, which is like the standard of flexibility. The lower the number, the more flexible it is. So you can start considering something like rubber. Rubber is around 50A, 45A, which is too flexible. And then you have something like PLA, for example. PLA will be 100D, maybe. You have TPUs that can also go to 70D, which is very, very solid, but it still has this range of flexibility. For something like RC cars or something that needs to be impact resistant, that's useful. So it's not like, okay, if I'm going to use TPU, it has to be flexible. No, because you can vary the flexibility if you have the additives.
I was just looking at the structure of TPU on Google, and it was just like you were mentioning how there is that balance there of there's like a soft segment and like a hard segment, and like the hard segment has like these benzene rings part of the structure, whereas the soft segment just has like two oxygens attached. So I'm just trying to tie all of the like chemistry that I learned from Orgo into like this specific application, but it's starting to make more and more sense.
Yeah, no, I can imagine. I think that is very interesting. When I was working with these guys, with the chemical engineers, they were always talking about new different ways to make something more flexible. I didn't understand it because my thing is electronics. I'm more in charge of the machine itself and how to process their information into that. But they were like the chefs. So they were putting a lot of pellets there with things. I was like, guys, do your thing. You are amazing, but I cannot get how this works exactly.
And one thing that I'm pretty passionate about is tying the fundamentals that we've been talking about to the applications. And so we mentioned this medical standpoint, and I think one thing you talked about is like exoskeleton. So how could that be an application just through the use of flexible materials?
Right. So exoskeletons nowadays, you have the issue, you have the ideal exoskeleton. When you imagine exoskeletons, you imagine something like Iron Man, you imagine something that is
Mhm.
comfortable and powerful, but in reality, it doesn't happen. The reason is because there are physics involved, and metal, which is the material that we use, titanium, steel, it's too heavy, super heavy. So it's
Mhm.
very hard to enhance human strength while keeping it comfortable.
Mhm.
That's why with a flexible structure, a compliant mechanism, or a mixable structure, mixing rigid materials and flexible materials, you can put everything in place, like the
Mhm.
body. You are not completely flexible, you are not completely rigid. You have a solid part inside that is your main structure, and then you have soft things in your hands, in your elbows. Your joints are flexible, your joints are compliant mechanisms. That's why an exoskeleton, it's ideal if you make it with flexible joints or compliant mechanisms.
Awesome. So let's move on to another application then, which is fashion, which you just touched on a little bit earlier. And so, I've seen on your Instagram, you've printed like actual shoes using these flexible materials, which I think is just so fascinating. And I was just wondering, considering raw material and processing costs, how do you see these types of materials making an impact in the fashion industry? Is there like a specific niche for it, or what's the deal there?
We are very lucky because we are having this today is August. So it's August 2021. We are very early. This is the early beginning. However, I still have, this is the
Oh,
shoe that
wow.
I printed. So
Wow.
as you see, it's completely comfortable. It's lightweight.
Mhm.
You can wear it. You can make it for your feet because you can vary any type of size, any type of shape that you have on your foot. You
Mhm.
can make it with a 3D printer. Therefore, there is a need. What's the
Mhm.
issue? To make these, it takes me 32, 38 hours to
Oh,
print
wow.
one shoe. So that's a challenge that we have nowadays because with a traditional injection molding or traditional manufacturing, you can have 10 people assembling these. You are going to make 100 of these in 1 hour.
Mhm.
That's the challenge. And that's why, in terms of profitability, in terms of margins, traditional manufacturing is more efficient nowadays.
Mhm.
However, how much does it cost to make something like this? Any tough? What do you think? Any guess?
Um, I would
Cost.
say like if we're just talking about raw materials, I could see that taking like, I don't know, 30, 50 cents,
Oh,
maybe.
30,
Wow.
50 cents. I was thinking like $5.
Well, we're very close. We're very close. So a spool of filament of flexible material, it's around $30.
Oh,
And with
wow.
that, you so a spool, but with one
Uh-huh.
spool, you can make around 6, 7 of these.
All right.
So
Good
you're
job,
I
very
think
Piggy.
that was
close
me. I think I
to
got
Yeah, yeah, yeah. Good job, Piggy.
five, ten
it.
dollars per shoe. And that's in the beginning because the spools are gonna
Mhm.
be cheaper and cheaper and cheaper until a point that it's gonna be easier. Because what's the point of you going to Amazon or Walmart or any other
Mhm.
store to get your shoe when you can make it at home? It will take 1 hour and you're gonna make it with any color for your feet, custom made, any material. You can add whatever you want. This is what is known as mass customization.
Mhm.
You get what you want for you. It's tailored.
Mhm.
That's the future that I see.
Yeah. That is awesome. I have a lot of follow-up questions. So I guess first off, I just really want to know, have you tried wearing it? Is it comfortable?
Yes, I have the video. If you check my social media, it feels like Crocs. When I put a video, people are always saying, "Wow, it looks good," but how does it feel? Since
Mhm.
you cannot transmit how it feels, this is
Mhm.
what I always answer. Use Crocs. It feels exactly like Crocs. Lightweight, very comfortable. People give me the feedback, for example, oh, it's not breathable, you need to make holes. And I said, well, yes, I didn't think about that. So there is always room for improvement. And I
Mhm.
think that I can make any type of design. If you know about shoes, this is the Yeezy. It's a very popular design. I just remake it and made it for 3D printing. It's amazing. It's my favorite creation. And I'm making another one that is coming very soon. It's amazing. You can use them. It's comfortable. It's lightweight, and it's just fantastic.
Yeah, I was gonna say it looks just like an older brother of Croc. So, and
Yeah.
that can come in. But one thing that I wanted to ask you about, especially with 3D printing, is the idea of customizability. So when you think about it in a broader sense in consumer goods, and for like if you ever use like Uber or Lyft, part of their business model is making a customized experience for you. So it always says like, "Hello, David. Welcome to like X city," right? They're trying to make it so that it feels more personal, and you see this in personalized ads and all sorts of things. And so 3D printing is like the next step up. Everything can be custom made without giant changes in your infrastructure or other things. So I guess as a 3D printer enthusiast, how do you kind of see the industry going in the future? And do you think customizability is like the number one selling point for 3D printing processes?
Absolutely, yes. Absolutely. I think that the fact that you can customize everything without changing the supply chain is just the next step. It's like this utopia that you want to live in. You don't want to go to a shop and spend hours and hours trying to find something that fits for you. You just make it for you. It's easy, it's fast. The problem is that nowadays it is not simple enough. If my grandmother can't use a 3D printer, then 3D printing is not easy enough. That's the process. That because I'm very optimistic about the technology, but also I receive hundreds of comments, messages, DMs every day saying, "Hey, I have this problem with my 3D printer. How can I fix that?" So I open my Discord server, and we have a community fixing 3D printers every day. So every day we are there trying to find how to fix your 3D printer. And I understand that. I understand that people don't want to spend hours fixing the 3D printer. They want to make things with the 3D printer. That's the challenge, but that's something that over time, like with what happened with computers, it was for hobbyists. It became, now we are speaking through a computer.
Yeah.
So it's the path that we need to leave.
That reminds me, when I was interning at GE Aviation, it was a similar story where the 3D printing of metals is also something that is very much up and coming, but in the beginning stages. And so with GE Additive, it's still like it takes a lot of time to really figure out and fine tune those processing parameters to be as efficient as possible. And it seems like that's kind of the idea that you're sharing as well, in terms of on a mass scale, getting everybody to own a 3D printer.
Yeah, correct. And that's another thing. For example, with the material, you mentioned printing with metal. People always ask me, why you're not printing with metal? And the reason is I've done it before, but it's not safe. I'm not willing to promote something that is not safe for people. So there are many debates around 3D printer can cause cancer. 3D printer can have the microparticles. You can breathe things. There are many articles about that. And of course, you're melting plastic. However, according to the research, it is completely safe. It is as safe as using a computer, as using a phone. You have radiomagnetic waves. You have cancer can happen for many reasons, right? So it's very hard to point it that 3D printing is the reason for that. No, because I will have cancer already. That's not the point. However, there are different types, different processes for 3D printing. For metal specifically, you have to temperature, everything above 400 degrees is dangerous, because the fumes that it extracts is dangerous. That's why, and the post-processing, it's even worse. So with a 3D printer, you just have to remove the support. But with a metal 3D printer, you have to put it in a furnace. You have to use a mask, glasses, gloves, and it takes hours just to clean up the part. That's why 3D printing, if it's not safe, it will not happen at home. Safety is first, always.
And then I guess going back to what you said in the first part is that it said you took 32 hours to print that shoe. And so I'd say safety is definitely a number one priority, but then time aspect is probably another large priority. Can you kind of just walk us through how you think that the time that takes to print these more complex shapes will go down? Like, do you have any ideas about what technologies or what processing capabilities will improve to reduce the time?
Yes, one of the reasons because it is slow is because the extruders that are used nowadays were made for rigid materials, right? Taking the point that not only flexible but regular materials need to be improved is because you need to move, or you can change the process. You can use lasers. You can use, there is a technology that HP is using nowadays. It's very expensive. A 3D printer from HP is like $100,000.
Oh, wow.
But it's very fast. It is amazing because they have this thing that is called voxel. A voxel is the 3D version of a pixel. So they can control every voxel with a different color, with a different material. So imagine it making any cubic millimeter with a different color, with a different material. The level of precision is incredible. However, with that, you can also increase the time. That's why something too complex nowadays is not a good idea, or it's very expensive because you need to decrease time. So how to increase the efficiency in time? Either make better technology, faster technology, or something that is completely disruptive that we don't have nowadays, but we will, hopefully.
So you mentioned this idea of getting everybody to own a 3D printer, which could affect this or create this digital supply chain that could reduce shipping amounts. And so one thing that you continuously bring up is, first of all, the time and then the complexity. So do you have any thoughts or any ideas on how we can reduce both of those factors? I mean, you're making an impact with your community, but how can we scale that up to everybody?
Yes. I'm very optimistic about digital manufacturing. As I said, you get your product online. You don't have to ship it because it is online. It goes through internet and you receive it at home. What's important? The input and output. So you need a designer, someone that provides the product, and someone that receives the product with a 3D printer. The first step is people adopting 3D printers. If they have the 3D printers, then you can digitalize products. Nowadays, for me as a designer, it's not very profitable to make this type of supply chain because unfortunately people don't use 3D printers at home. And the vast majority of 3D designs, 3D models are available for free. Why? Because people are not willing to spend time, engineers like me, to spend hours making a design when you're not going to make $1 or $2. Therefore, the first step for digital manufacturing is adoption of 3D printers. Then how to scale it? You need a system that is simple, that you just create the design, you customize it for you, and you receive it. Easy, fast. The technology for that, I was making a beta test with my followers. It was for a couple of months. It worked. You just scroll with bars, and then you were able to customize your model with your size. I had this shoe, so you can put it for your size. You can put different types of design, different patterns. You could make that with your phone. Now, the phone with 3D printers, you need a computer. So that's the extra step that you have to put in because you need a slicer. The slicer processes information for the 3D printer. So once we remove everything that we can use only our phones and our 3D printers, that's going to disrupt the technology. That's going to disrupt the supply chain.
Yeah.
See, David, that's why he's trying to get us to buy a 3D printer.
You should buy a 3D printer.
Yeah, no. I think that's awesome. In my head, like in the future, I'm gonna like go on my phone and I want a new pair of shoes, and I'm just gonna put it on my phone and it's gonna start printing. So that's awesome. I guess when we talk about that shift to digital consumerism, Um, can you like, you just described such a different future from how we operate today, right? So what is your timeline for like seeing this change? I know it's a very hard question, but you are by far the most knowledgeable. So I just want to kind of pick your brain about how you kind of see this unfold.
So we can take as a reference what happened with newspaper, for example.
Mhm.
Newspaper run it in the world for years, hundreds of years.
Mhm.
Once we have phones, once we have computers, is when we start seeing, okay, the shift from physical to digital.
Mhm.
When we compare 200 years with the last 20 years that we have had phones, like really, really good phones, smartphones, then we see like it is nothing. We just started with this. So with 3D printers, it's even harder. We are talking about an entire product, the consumer good. We have different materials, we have designs. How long could it take? I will say in 20 years, this will start to happen. So let's say from now on, and we can play this in 20 years, 2040, I will say that we will start having the beginning of digital manufacturing.
Wow. I'll make note of it.
Yeah, yeah.
Let's put the event here.
But that makes sense. I like that analogy because the second everybody started to have a laptop or, you know, a smartphone, then that's really when you can see like the decline of newspapers. So it seems like that'll be the same case. You know, when we start to see everybody own a 3D printer, then you can probably see a rapid increase in, I guess, this timeline for digital supply chains and whatnot.
Exactly. And it happens with many technologies. Same thing with e-commerce. In the beginning, it was very hard to imagine something that you buy online.
Yeah.
But here we are having Amazon, having eBay. So it's hard in the beginning because, as we said, the adoption takes time, and people don't see further than what they have, and people critique a lot. You can see the comments that I receive. They are brutal. They are hateful. You're dumb. You can't do this. It doesn't make sense. We already have this technology. But if you don't imagine beyond the limits of what we have, then we don't have progress. And progress is what drives humanity. And here we are.
Yeah. Well, one of the craziest things that I heard a while ago is that like we only started flying, like the Wright brothers like took off like over like a little bit over 100 years ago, and we've seen such an exponential curve. Like if we go back, and like my aunt is like 70 years old, if we go back to like when she was born, and we go to like now when my nephews and my nieces are born, it's just such a crazy paradigm shift between the two. And like I think that potentially we could even see like a even higher shift with a faster technology growth, that maybe we come back here a little earlier than 2040 in the perfect case. But I just think you're right. Until like we start pushing the boundaries of what we already know, then we're never going to make any true change.
Exactly. And we can see the example also. I'm very passionate about the history of technology. With computers in the beginning, people were saying, oh, one of the top firms, financial firms in the world, they were saying in the 1960s, well, we are only going to need 5 computers in the world. That's it. Because we didn't have the necessity. We didn't know the possibilities of that. And even here, we don't know the possibilities of 3D printing. I'm just talking about consumer products. There are many things that there are people printing biotechnology. They are printing arms. They are printing eyes. They are printing limbs. That's a different game. There are people printing that. The material is key. People printing food, people printing organs. It's a different game. What are the possibilities? We don't know. We will know.
Yeah, there's endless possibilities. You kind of just gave a sneak peek to a future episode. We'll be doing one for 3D bioprinting soon. So
I need to watch it.
Yeah, we'll send you the link. But going back to TPU for a moment, so often you made this comparison between TPU and PLA. And so a wide range of properties for TPU seems to outperform PLA, but it seems like maybe the relative cost might be a little bit higher. So does that indicate why it might be used for only certain applications compared to PLA, or what are your thoughts here?
Yeah, price point is important, but nowadays you can buy PLA for $20 and TPU for $30. So the
Mhm.
difference is $10. People are not very, they can do it. They can afford an extra $10 for a different material. But printing speed and quality, it's a major player. And also the color. There are not many available colors for TPU, unfortunately, because yes, it has lower margins. Companies don't make too much TPU because people don't buy too much TPU. And therefore, that's the difference. I think that is getting better and better now. It started 3 years ago. We only have like a couple of companies, and we only have black, blue, and green, and that's it. Now we are seeing like better colors. We see brown. At least we have brown. We have orange, and I appreciate that. I really appreciate that.
And I feel like maybe there will be more and more manufacturing when there's more applications it can, or like increased demand and more applications. So what does the future look like for TPU? Is there more applications outside of the ones you mentioned, consumer goods, fashion, and soft robotics?
I think that it depends on what people want to explore. Even with PLA or with any material, you don't know the possibilities until someone make it.
Mhm.
So for example, people are making business a lot of money based on 3D printing. People are selling gifts, people are selling things that are cheaper and easier to make with a 3D printer. So what are the possibilities? I think that businesses, especially here in the US, drive a lot of this technology and accelerate the process. So until we find someone, hopefully me, that figure out a way to expedite the process for TPU, then is when something is going to happen. In my case, like since we are talking about this, I'm about to launch my website. And for my website, I'm only going to make designs for TPU. With this, my is to expedite the process of adopting TPU. Because as I mentioned, I work in a manufacturing facility. I'm trying to make my own TPU. It is very hard. It's super hard. But once I have designs and good materials, then there are no excuses. Hopefully. And that's my plan.
Awesome. Yeah, that kind of leads us into really good questions that I think you're kind of a living testament, because you said you started in 2019, you bought a 3D printer, and now you lead a very popular TikTok channel and you have lots of hundreds of thousands of followers. So we're just really curious, what is next for you? What are your next big plans? You kind of just talked about how you want to bring TPU into the light, but beyond that, what else is in store for you?
The ultimate goal is disrupting the manufacturing supply chain. So as I've said, digital manufacturing, that's the ultimate goal, to change the way how we make things. That's the mission. That's the goal. The vision is what we were talking. You just grab your phone, look whatever you want, you make it, you have it at home. For that, it is a long process. From now, my next step is opening my website with designs, something for consumer goods, soft robotics, wearables. After that, the plan is to launch the TPU brand. It's going to take longer because I thought you were very optimistic in the beginning. Once you're making it, you see all the complications that TPU have in terms of manufacturing. I was thinking, yes, I can make it recyclable. I can make it with cardboard. I can make a lot of things. But once you make it, you see that the price goes up to $100 per spool. So you have to start fighting with the market and competing against China, against India, other countries that make it at a very price. You need to compete, and to compete, you need to be better.
Wow, that's a great project and amazing vision. So for our audience, follow him at DavidZIndustries to stay tuned with that project and just hear more updates. But we've covered just a wide variety of topics today, from your persistence with creating, amazing Instagram videos to, just like you mentioned, starting your own business, revolving around TPU. So it's a very unique and inspiring path, especially for me, that you've forged. So I was just wondering, what advice do you have for material scientists and engineers who maybe want to pursue a non-traditional path, like creating content on Instagram or, creating this business?
There is a niche for everything. I'm very excited when I see people trying new things, especially when there are things that are not conventional. In terms of material science, there are so many things that people want to learn, but they don't know where to find it. Create content, make that content and make it appealing. That's the key to increase the community, not your numbers, but the community. Community is first, the numbers go after that. And never give up. That's the most important. In the beginning is so hard because you are working extremely, extremely hard, so many hours to get 3 likes, 10 likes. After a while, you're gonna be rewarded. Never give up.
I love that. Yeah, I think that's key. Persistence is important, and it's really just doing what you love. And I think everything else will follow.
Yes. Yeah. If you have a goal, pursue that goal. If you get a community with that goal, even better.
Yeah, I think that's so empowering, especially because when you start, you can't expect people to listen because you just popped out of nowhere. And so you really do have to just shout into the void. And then you kind of just have to hope you can market as much as you want. But if you are providing value and you're passionate and you keep on creating good content, then the people who you want to follow, not just anybody, the people who are passionate that you want to interact with will come join. So I think that's great. And I hope that your TPU project is going to take off. It sounds so exciting.
Thank you very much. If one day you get a 3D printer, let me know and I will send you a sample of TPU. Awesome. I hear my community, I always interact in the comments, and that's why I think that it helps a lot. And that's why of the most important things that I have, because I have instant feedback. As soon as I post something, people either criticize it brutally, but sometimes good. Therefore, I'm able to improve myself. And if you can improve yourself, always listen to them. They are always right. And that's how you can create and grow your business, your passion, and whatever goal you have.
Yeah. No, that's what we love about our Discord community, is just like engaging with people and hearing their stories whenever a new person introduces themselves. It always makes me happy because they're so passionate about material science, just like David and I. So, all right.
Thanks, guys. It was such a pleasure. Thank you very much for having me. I hope to see you soon.
Thank you for tuning in to this episode of the It's a Material World podcast. If you enjoyed the show, consider subscribing and hitting the like button down below. And if you'd like to support us on this journey or simply show off your love for MSC, we actually released merchandise. And if you'd like to check out more of the designs, visit itsamaterialworldpodcast.com/shop or use the link in the description. We'll see you soon. And in the meantime, go change the world.